Hi everybody, in this video we're going to talk about multiplication. We're going to start with a really simple model of multiplication, which is just there's a row of 4, there's a row of 4, there's a row of 4, so that's the same as saying 3 times 4, or 3 rows of 4. So if you have 3 rows of 4, you're going to have 12 smiley faces. Then the other way to look at this is you could start with a row of 3, and you could say, there's a row of 3, and here's another row of 3. And so in the end, we have 4 rows. We can think of it as, here's a column of 3, here's a column of 3, here's a column of 3, here's a column of 3. We can think of it as 4 columns of 3 smiley faces. And that's because multiplication is commutative. You can do it in either order, 3 times 4 or 4 times 3, and you get the same thing. But what I want to talk about is multiplication as area. So before, when we had our 3 rows of 4 smiley faces, we thought of them just as objects, right? But I could put 1 smiley face in each of these boxes, right? Whoops. There's 1 smiley face. There's here's another smiley face. Here's another smiley face, right? And I could do the same kind of 3 rows of 4 thing with the boxes, with these smiley faces. Or I could just think of them as boxes, as area, right? So, whoops, let's get these smiley faces out of here and just think of this as area. So here's 1, 2, 3, 4 boxes, 1, 2, 3 rows. So this is a 4 by 3 rectangle that I just drew here. And I can color it in so that you can see. This is a yellow 4 by 3 rectangle. So area and multiplication are the same thing. It's a great way to show students multiplication is to look at area. So now let's suppose instead of doing small numbers like 4 times 3 is 12, we wanted to do something much larger like 23 by 15. To do that, we want to start by counting out 23 going across the top like this, and then 15 going down. So, and the key here is we have to have a rectangle. You can't have a funny, odd, lumpy shape. It has to be a rectangle. And we're going to find the area of this 23 by 15 rectangle. So let's count it out. And we're going to make our life a little easier. We're going to stop at every 10 and mark off every 10 boxes going across so that we know where the 23 by 15 rectangle ends more easily. All right, so far I've counted 10 going across the top here, 10 boxes. And now I'm going to count another 10 boxes out going across the top. So here's another 10 boxes. It ends right here. My 10th box ends right there. And then we're going to count out 3 more, 1, 2, 3. And that'll be 23 going across the top. And now we want to count 15 going down, starting with the corner box, and we're going to count to 15. And again, I'm going to mark off my 10. So I can count 15 going down like this, but I can also count my 15 going down like this from here, either way. So here I've counted 15 going down. This is my 10th box. It ends here, and then 1, 2, 3, 4, 5 more. Now, here's the most important part. This is supposed to be a rectangle, right? So we have to color in all of this rectangle here that we've marked out with our 23 boxes going across and our 10 boxes and our 15 boxes going down. So now imagine your base 10 flats. Imagine you have a 10 by 10 flat that's square. In the base 10 blocks, where could you put that starting in this corner? And how much area would it take up? So if you had a 10 by 10 flat, here's 10, here's 10 going down, right? So a 10 by 10 flat would fit this corner Then imagine, could you fit in another 10 by 10 flat, and where would that go? So pause the video for a second and imagine that. So here are my two 10 by 10 flats in my rectangle. Now what I want you to imagine is the rods. So remember, a rod is a 1 by 10 rectangle, and it looks like this. It's a tall, skinny thing, but it could also go across here. This is 1 by 10 or 10 by 1, right? And then you could also fit in another rod here in this area. So right now, pause the video and imagine filling this whole place up with as many rods, not broken rods, whole rods that you could fit in here. And where would they fit? Pause the video and check it out on your own. Now here we go. Here are my rods, and notice I can fit 1, 2, 3 rods here. I colored them orange so you can see them better. And I can fit how many rods here? 1, 2, 3, 4, 5, and another 5, 10 rods there. And then what ends up left over in this corner? Well, this is for the units. So the units we can color in a different color. And it looks like this is a 3 by 5 rectangle. So there are 15 units in this area here. Now, these flats, rods, and units correspond to the parts of multiplication that we get when we use partial product multiplication. So let's take a look at that and where we see all these flats, rods, and units in our partial product multiplication. Now, just a warning, as grown-ups, we're not used to multiplying like this with this area, right? So it might be easier for you to get your partial products first and then make this picture, but the really important thing is it has to be a 23 by 15 rectangle, and then all your pieces are going to just fit in. So here are my partial products. To do the partial products, we write 23 by 15 as an addition problem here. So as 20 plus 3, right? And then as 10 plus 5. So 15 is 10 plus 5. Now, we then use the distributive property, which you already know from doing this, right? X plus 3 times x plus 5. So we're going to use the distributive property to get all of our parts. Just a reminder, when you use the distributive property, what you do is you do the x here times that x there. And that's going to give you x squared, right? X to the second power. Then after you've done your x times your x, you're going to do the x times the 5. You might do this in a different order, but this is the basic idea, right? So when you do the x times the 5, you get 5x. Oops, forgot the plus 5x. And now you do the other two parts of this distributive property. You do the 3 times each thing, the 3 times the x, and the 3 times the 5. So you get plus 3x. 3 times x is 3x, and then 3 times 5 is 15. And you can combine like terms in the middle, right? So that you get x squared plus 8x plus 15, if you want to write it like that. So how is this similar? Well, it's the same idea. You're going to do the 20 times the 10. Then you're going to do the 20 times the 5. Now, 20 times 10 is 200. So we're going to write 200. And then 20 times the 5. 20 times 5 is 100. And then we're going to do the 3 times each one, just as we did over here. So the 3 times the 10 is 30. And then the 3 times 5 is 15. Now, when we add all this stuff up, what do we get? Let's see. 200 plus 100, that's 300, plus 30 plus 5, 345. 345 is the same thing as if I take my trusty calculator and do 23 times 15. I get 345. Ta-da! Now, you might be saying, but boy, this is harder. doing it this way, right? It's always harder when you do something you're not used to. It might be easier to use this horizontal method here, where I do the 3 times the 5 is 15, and the 3 times the 5 times the 20 is 100, and then the 10 times the 3, that's my 30, and then the 10 times the 20, that's my 200. You get the same pieces. And now, what's nice about all of these pieces here is that when I add all of this stuff up, right, I get 200 plus 130 plus 15, I get my 345, my answer to my multiplication problem, but it's also in here. So here are my two flats. That's my 200 right there. That's that partial product, because this is 100, and this here is another 100. And then over here, my 3 rods, that's my 30. That's this partial product here. And these here, all these rods, that's my 100, that 100 here. So 100. And then what's this here? That's the units that are left over at the end. That's the 15. So I end up with a picture of all the partial products. Now, you still might not be convinced that this is a good method, right? Because boy, does it take so much longer than just going 23 times 15, nice and easy, and I'm gonna do the 3 times 5, and I get 3 times 5 is 15. I put down the 5, and I'm gonna carry the 1. That's what makes this harder for kids, is that you're adding and multiplying at the same time. Whereas if you do this partial products method, you multiply everything first and then you add it afterwards. So I think partial product multiplication is a good building block to use temporarily until you get to this method, or until you use the lattice method, either one. I hope you enjoyed it, and feel free to ask me any questions.